For many years, there's been a need for an improved shipping connection between Amsterdam and the River Rhine. The problem was studied carefully, and finally plans were agreed upon for the Amsterdam Rhine Canal. This will shorten the shipping routes between Amsterdam and southeast Holland, Belgium and the Rhine countries. The existing Merwede Canal from Amsterdam to Utrecht, which forms part of the new canal, had to be made wider and deeper. The newly constructed stretch from Utrecht crosses the river Lek near Wijk bij Duurstede. It then continues to the river Waal near the small town of Tiel. Locks had to be built to deal with the river crossings, and bridges had to be constructed as well. The stretch between the rivers Lek and Waal is open to the Lek except for about 10 days a year when the river is at its highest level. Consequently, the water level in the canal varies considerably in this stretch. This is a cross-section of the left bank. The water level varies between 1 and 5.5 meters above New Amsterdam level. The 2 in 5 slope is protected by an asphalt revetment from 3.65 meters to 0.5 meters above the New Amsterdam level. In the case of the right bank, the protection continues to 4.5 meters above New Amsterdam level. The width of the protective asphalt grouted revetment is about 14 meters. At the foot of the revetment, there's a timber support consisting of a row of piles and boarding surrounded by a drainage trench. Water which may collect under the revetment can thus drain into the canal. The order in which the work is carried out is first of all to dig out the canal banks. Then the banks are protected with the asphalt revetment for a distance of about 8 kilometers along each bank. After this, the canal is deepened. During this work, water must be kept away from the site, and so pumps are kept running day and night. A drag line is used to remove the large quantities of earth. This job requires great skill in order to maintain the correct profile. Following the drainage trench, we can see the construction of the toe of the revetment. Piles 1.5 meters in length are driven into the ground, 7 piles to every meter. Boards placed behind the piles complete the support for the revetment. In the meantime, the drainage trench is dug to the correct depth. With the piles and boarding in position, the work of placing stones in front and behind the row of piles can begin. Here the first lot of stones is emptied into the trench. The stones are spread by hand until the level of the boarding has been reached. Here is a completed stretch. This concrete beam is laid at the top of the asphalt facing to prevent water seeping under the revetment. In some places it supports a further protection of bricks. Rough limestone is now laid on the slope to form a low-cost protective layer. The pieces of limestone measure about 10 by 15 centimeters. They are laid by unskilled labor in a layer of fine sand. The limestone is then tamped into position. While all this is going on, the asphalt mixture required for grouting the stones is being prepared. This is the asphalt mixing plant of the Hollandse Betonmaatschappij. Equal parts of coarse river sand and fine sand are put into the bucket elevator. This raises the sand to a drying drum, where it is heated to a temperature of between 180 and 200 degrees centigrade. After a fixed quantity of sand has been weighed into the mixing chamber, the filler is added, followed by the bitumen, which has been delivered by tank lorries from the Shell refinery at Pernis. After the asphalt grout has been mixed for 1 minute, it is poured into a container. This container raises the asphalt grout and tips it into an insulated hopper. The hopper has a lid which opens automatically for filling. This is the lorry which transports the grout to the canal bank. Its tank is fitted with rotating paddles which prevent the sand settling during transport. The last batch of mix is tipped into the hopper. The waiting lorry is filled from the hopper. The lorry is brought as near to the slope as possible, where work is now in progress. The asphalt grout is poured from the lorry into a chute, which is used to direct the hot mix wherever required. The mix flows along the chute and pours onto and between the stones. Squeegees are used to spread it evenly over the surface and to prevent too thick a layer being formed in any one place. The pouring and spreading of the hot mix continues until the layer of stones is completely grouted. The quantity of mix used naturally depends on the voids between the stones, but on an average it amounts to 80 to 90 kilograms per square meter. This is a useful piece of apparatus, a chute on wheels. It's used if the distance between the lorry and the work is too great for the usual type of chute. The tank is tipped in order to remove all the mix, and the chute is scraped clean to prevent it becoming clogged. Here is a stretch of completed asphalt revetment. A start can now be made in clearing the earth between the banks. This is done with a suction dredger equipped with revolving scoops. The mud is pumped away through this pipeline. Now the size and contours of this great undertaking are becoming clearer. Only a short stretch remains to be completed. The asphalt revetment will provide adequate and durable protection for the canal banks, although the construction and maintenance costs of this type of surfacing are low compared with other methods.